Morning everybody. Today we learned how to simulate power supply using LM7805. This is a transformer. The turns ratio is 20:1. The input is 240 volts. I need a voltage of 12 volts. That's why I took a transformer whose turns ratio is 20:1. To change the turns ratio, double click the transformer. In the primary coil and the secondary coil, you can place the number of turns. Here, the primary to the secondary ratio is 20. Therefore, input voltage is primary voltage is 240 volts and secondary voltage is 12 volts. This is a bridge rectifier directly available in the Multisim, and the number is 3N248. Okay, to place this, you just double click here, and you can see that in the diodes. Okay, in the diodes you find the 3N248. Okay, and coming to this capacitor, 470 microfarads, and this is the what you call the actual voltage regulator IC LM7805. You can double click that and you can see, you can find different things: LM7805, 7809, 7812, 7815, 7818, 7824. So here my intention is I want to need a 5 volts output. That's why it's LM7805. The importance of LM7805 is the minimum input voltage required is 7 volts and the maximum input voltage is 35 volts. In the range of 7 to 35 volts, the output voltage is 5 volts and the maximum load current it can provide is 1 ampere. Let's check that whether the circuit works or not. Start simulation. Here the idea is we are varying the load resistance from 470 ohms to 22 ohms as in the manual, as in the tabular form. So I simply first select the load resistance value is 470 ohms. For changing for that, you just double click the resistor and enter the value and run the simulation. You identify that the output voltage is it is around. It just takes some sort of time because you are starting simulation. It takes some time. Clearly identify that the input voltage is, the secondary voltage is 12 volts. The output of the bridge rectifier is 14.6 volts, which is greater than 7 volts. Therefore, if I provide this input voltage to a regulator, I get a constant output voltage. Okay, again I simulate. You got it. It takes some time because simulation lagging. It takes some time the first time. And a load current of 10.6 milliamperes and the input voltage of our load voltage of this, and stop simulation, change to 330 ohms, run simulation. Stop. 220 ohms. The next value is 47 ohms. So when a load is increases, the load resistance value decreases, the load current increases. Even the load current will decreases, the output voltage remains 5 volts. It is clearly observed. You just observe. So still now decrease the load resistance, that is the load current is increased. So previously 106 milliamperes, now it is 151 milliamperes. 22 ohms is around 226, 27 milliamperes. Okay, down to 20 ohms to 10 ohms. The load current is around 500 milliamperes. If I further decrease the load resistance, that is, I want to increase the load current, I make the load resistance is 5 ohms. It is almost nearly 1 ampere, 936 milliamperes, but the load voltage is decreased. The rest is the maximum load current it can provide by 7805 without a heat sink is 1 ampere. So that is the reason. If I still further decrease the load resistance, say 2 ohms, let's see what happens. See, the current is there, but the output voltage is not 5 volts, it is down. So in this situation, the regulator does not regulate it cannot regulate the voltage. So this 7805, that is the reason the 7805 is, even though it gives a fixed 5 volts for a maximum load current of 1 ampere. Thank you.